Okay. In this video, we're going to knock out 18 through 28 here. So we want to look at 18 through 23 first. Some of these require a little bit more room, so I've got all the functions f of x, g, h, and s of x all written down here, and I'm just going to go through these kind of one by one, starting with 18, which asks me for f of g of x. What is this equal to? Well, f of g of x, that open circle is not multiplication. If it was a closed circle, then that would be f times g. But that open circle is actually function composition. So this would be read as f of g of x, or maybe you write it like this. F of g of x. And this is asking you to basically take g of x and plug it into f of x. So g of x here, what is g of x? G of x is x plus 1. So I'm taking g of x, plugging it into f of x, and then using the rule for f of x. F of x plus 1 is x plus 1 squared. Okay, realize f of anything is that thing squared. So f of x plus 1 is x plus 1 squared. And x plus 1 squared is asking you to multiply it by itself, which is a foiling problem, which you should get this. I'll let you check that on your own. Okay. What about 19? What is h open circle g of x? Well, you should be able to read this as h of g of x, which is asking you to take g of x, plug it into h of x. So that's h of x plus 1, right? Realize g of x is x plus 1. And then we're going to take the rule for h, which is negative 4 times whatever's in the parentheses minus 2. So that's going to be negative 4 times x plus 1 minus 2. Distribute negative 4x minus 4 minus 2, which should give a final answer of negative 4x minus 6. Cool. All right. There's that. 20 asks for s of g of 2. This could be written as s of g of 2. So basically this is asking us to find g of 2 and then plug that into the s function. So remember, g of x is the function x plus 1. So then what's g of 2? Well, g of 2 is 2 plus 1, or 3. So g of 2 is 3. So I'm going to take this and plug it in here. So ultimately we're finding s of 3. S of 3. What's s? Well, let's remember what s of x is. S of x, according to the rule on the paper, is negative 2x squared plus 3x minus 1. So then what's s of 3? That's negative 2 times 3 squared plus 3 times 3 minus 1. That's negative 2 times 9, 3 squared, plus 9 minus 1. Very quickly, negative 18 plus 9 minus 1 is negative 10. Negative 10. Cool. that's all I'm going to do for 18 through 23 there. I'll let you do 21, 22, and 23 on your own, and then check your work against the key. And so then the last thing we're going to do is 24 through 28 there. 24 through 28 looks like... here. Sorry, I'm having some computer issues. Okay. So here's the function f of x. We should already remember what f of negative 2 means, f of 3 means. So let's find out. What's f of negative 2? So when x is negative 2, y is 3. So f of negative 2 is 3. Plus f of 3, when x is 3, 1, 2, 3, y is 2. So that's 3 plus 2, or 5. Pretty easy stuff. What's f of 0 minus f of 4? Well, f of 0 is 0 minus f of 4, 1, 2, 3, 4. When x is 4, y is 2. And 0 minus 2 is negative 2. Notice the difference in the operation in 26 versus the operation in like an 18. This is multiplication, the closed circle. So what's f of 2 times f of negative 2? F of 2, when x is 2, y is 2, times f of negative 2, when x is negative 2, y is 3, and 2 times 3 is 6. Okay, last couple ones here. F of 3 divided by f of negative 2. F of 3 is 2 divided by f of negative 2 is 3. So that's going to be 2/3. Pretty easy. And then finally, what is f of 2? So just writing it bigger, what's f of 2? So I'm going to start on the inside first and just figure out what's f of 2. If I find what f of 2 is, so when x is 2, y is 2. So f of 2 is 2, and then I'm going to evaluate that again, f of 2, and then f of 2 is again 2. So there we go. What about f of negative 2? Okay, what would that equal? So let's just finish with this example. Well, the first thing I would do is figure out what f of negative 2 is, and then find f of that. So what's f of negative 2? Well, when x is negative 2, y is 3. So then what's f of 3? Well, when x is 3, y is 2. Okay. And that's function composition in a nutshell.